All right, welcome to 6.06. We're going to continue sketching trigonometric functions, and we're going to add into those sketches some details, things called the period, the midline, and the amplitude, which are characteristics of trigonometric functions that are going to help us a great deal in understanding real-world situations and modeling them with these trigonometric functions. Get started, we can never have enough practice really graphing these types of functions. And so I would suggest that you, on a fresh sheet of paper, just go ahead and sketch the graphs of sine and cosine of x, and use your unit circle to do so. Plot the points first, and then go ahead and complete your sketch of the graph. Here are the completed sketches of the graphs, and if you struggled figuring out how to do that, it'd be a good idea to, before you move onward, go back and refresh your memory watching 6.05. What I want to do right now is just kind of talk quickly about the relationship between cosine and sine and how they relate to the unit circle. So, sine, for example, is simply tracking the y-coordinate as I rotate around the unit circle, right? So at 0, the y value is 0, right? I haven't rotated at all, the y value is 0. And as I begin to rotate counterclockwise, the y value increases, right? So the y value increases, and I get to the top of the circle, and that's where I get the maximum of my function, and then as I continue rotating, I am now descending, right? My y value is decreasing, and so the value of sine is decreasing, and it will then eventually get to 0, and will continue to decrease and so forth until it reaches its minimum, -1, and then it's going to increase. And so really when we're graphing sine and cosine of x, what we're doing is we're saying, okay, let's move around the circle and let's graph the x or y coordinate as we move around the circle, and that's what we originally set out to do. And so this is why this graph, both these graphs look very similar to the sketch that we made when we were trying to model the Ferris wheel. I want to spend just a couple of seconds talking about the relationship between sine of x, cosine of x, the x value of my plot, and then also the unit circle. So notice here that these are the points. This is the cosine value, and this is the sine value, when the radian measure, the angle, is 0, right? So at that point here, the x value is 1 and the y value is 0. Hence, sine is 0 and cosine is 1. And so imagine that I keep traveling around, right? So sine is increasing as I rotate counterclockwise, and cosine is decreasing, right? And if you look at your unit circle, this makes sense. The x value is getting smaller and smaller, right? It's moving to the left. And the y value is moving upwards, so it's increasing. So sine is increasing and cosine is decreasing. And the x-axis here is simply measuring the turn that I've made, right? The sine of something and the cosine of something, that something has to be the rotation, the number of radians that I've rotated around my unit circle. So at any rotation here, the cosine of x is telling you the x value after that rotation, and the sine of x is telling you the y value of that rotation. And so, for example, think about when they're the same here. If I'm rotating around, I notice that cosine and sine are the same when the angle is pi over 4 radians. And sure enough, they're going to intersect right at pi over 4. Similarly, if I were to rotate, let's say, in between pi over 2 and pi, let's just pick a point here, right? Notice that the sine is going to be a positive value, a little less than 1, and the cosine is going to be a negative value, a little less than 1. And so if I think about in between pi over 2 and pi, and here's pi over 2, and here's pi, and so in between here, notice that the x value is some negative value, right? X value is some negative value, and the y value of these points is going to be some positive value, right? And so for some angle between pi over 2 and pi, we know that sine of x is going to be a positive value, and cosine of x is going to be a negative value. Okay, so hopefully that cleared up some confusion, and now we're going to take this one step forward. So here are a couple things for you to think about. Notice that you have seen these questions before, but now with a little more insight into the graphing of the functions, I want you to take a look at these again, go back and look at your previous answers, and retry them. Okay, so let's think about this first graph here, and is this going to be the sine of x or the cosine of x? Well, notice a couple of things. The first is that when x is 0, the value of this graph is 1. Well, sine of 0 is going to be 0, and cosine of 0 is going to be 1. So right off the bat, I know this can't be sine of x because sine of 0 is not 1. And so this has to be the cosine of x. We could check some other points, right? Notice cosine of pi is going to be -1, sine of pi would be 0, and so again we are confirming that this is cosine of x. Secondly here, we have this function sine of x, and we're told it's negative on the interval from pi to 2 pi. And so what we want to do is we want to give 2 more intervals on which it's negative. And so looking, just thinking about your unit circle, and I'll just quickly sketch out here, think about where sine is going to be positive and where is it going to be negative. So sine is the y value, and so all the y values above the x-axis are positive, and below the x-axis, the y values are negative. So if I'm rotating around, here I've rotated pi radians. Sure enough, between pi and 2 pi, they're negative. And if I were to keep rotating, right, between 2 pi and 3 pi, they're positive. All these y values are positive. And then from 3 pi to 4 pi, they're going to be negative. So another interval would be from 3 pi to 4 pi. And then if I were to keep rotating around, 4 pi to 5 pi, they're positive, and 5 pi to 6 pi, they're going to be negative again. So another interval is from 5 pi to 6 pi. And if you took a look at the graph, this would make sense. So just using this one up here, sine is going to look like that. It's going to be negative between pi and 2 pi. It's going to be positive from 2 pi to 3 pi, and then go negative again from 3 pi to 4 pi. Okay? So that's a good way of thinking about how the unit circle allows you to understand when sine is or cosine is going to be negative or positive. So we're going to learn these new terms, midline, amplitude, and period. And not surprisingly, the name of each of these characteristics tells you a lot about what that particular characteristic is. So I'm going to want you to pause the video now and try and just in your own words, or maybe by annotating the graph of your cosine function, this is cosine, what would you think the midline, amplitude, and period are of this function? Okay. Hopefully you got some kind of idea, and I bet you were closer than you think you were. Let's go ahead and take a look now at what these terms actually mean. So here are the definitions of midline, amplitude, and period. So let's go ahead and read through them quickly, and you'll want to definitely copy these down so that you have this in mind. I'm sure they're very close to what you came up with on your own. So the midline is the horizontal line that is halfway between the maximal and minimal line. The amplitude is the distance between the maximal point of a sinusoidal function. This is another word that describes a trigonometric function. We'll talk about it more in the future. Distance between the maximal point and the midline. And the period is the horizontal distance between the 2 consecutive maximal points or 2 consecutive minimal points on the graph of a sinusoidal function. So here's what we're going to do. I'm going to quickly sketch a graph of sine of x to use for reference. And if you want, you have a graph of cosine and sine already, and if it's close enough in proximity in your notebook, you can just reference that and point out the midline, amplitude, and period there, or if you want to recreate it here on this page, you can. All right, so here's my sketch. And let's go ahead and take a look at the midline. So on your own, try and find the midline of sine of x. Well, notice that the maximum is 1 and the minimum is -1. And so the line that is halfway in between and horizontal, right, is in between 1 and -1, which is at 0. And thinking about this, as the equation for a line, right, the maximal line is the line y equals 1, And the minimal line is when y is equal to -1. And so halfway in between is going to be the line when y equals 0. And so the midline is the line y equals 0. And I'll go ahead and add this to our graph. So the line y equals 0 is exactly that, the x-axis. Sadly, my straight line abilities are not that great, but that's the best I can do. Now I want you to think about, okay, if you had cosine of x graphed here, what is the midline of cosine of x? What you should see is that the maximum and minimum lines are the same for cosine of x, so the midline for cosine of x is also going to be y equals 0. All right, let's move on to the amplitude. Go ahead and try and figure out what the amplitude would be for sine of x. So notice that the amplitude is the distance between the maximum point and the midline. And so if I think about the maximum being up here, right, the maximum is at 1 and the midline is at 0, the distance between those two is going to be a distance of 1. And so the amplitude is 1. Now I want you to find the amplitude for cosine of x. What you should find is that you have the exact same situation, maximum value of 1 and midline of 0. Okay? And now the period. So the period is the horizontal distance between two consecutive maximum or minimum points. If I take a look here, notice that two maximum points, well, here's the first maximum point, right, at pi over 2. And the second maximum point occurs at 5 pi over 2. So what is this distance that I've traveled to get from pi over 2 to 5 pi over 2? And so what is that distance? And to help us think about that, let's consider our unit circle, right? So at pi over 2, here's pi over 2, and the maximum value is 1, right? And how long will it take me to get back to another maximum value? Well, as I rotate around and around and around and around and around and around, notice that I have to go all the way around the circle to get back to that maximum value of sine where it's 1. So if I go all the way around the circle, how many radians have I traveled? Well, we know that all the way around the circle is 2 pi radians, and sure enough, this distance is 2 pi, right? And if I were to do 5 pi over 2 minus pi over 2, well, you'd get exactly 4 pi over 2, which is 2 pi, or 1 time around the unit circle. Okay? So the period for sine of x is 2 pi. And you'll find that that's the exact same for cosine of x. All right, so now let's go ahead and graph some more sinusoidal functions, and we will look at what the midline, amplitude, and period of those functions are. All right, here we go. So let's graph function 3 sine of x on the graph below. Identify the midline, amplitude, and period. So you'll want to have your unit circle handy, and notice here that this is very similar to sine of x. It's just that we're multiplying by 3 here. So you should have some ideas of what might be happening to your function as you graph it. And what I encourage you to do now is pause the video and try it on your own. One strategy that you might want to use is to make a table of values. So start with 0 and then pi over 2 and then pi and whatever. Plug them in and actually calculate what your value is going to be using your unit circle. Okay, so notice here that I've set up a table of values, and this may be something that you are used to doing and you want to do as much as possible because you struggle with graphing, and that's perfectly fine. This is a great method to make sure that you don't make mistakes. And of course, if you don't feel like this is an efficient use of your time, that's perfectly fine. You can graph this pretty easily without making a table of values. But starting out, so when x is 0, my function will be 3 times the sine of 0. And if I look at my unit circle, right, if I don't have it memorized by now, the sine of 0 is 0, right? And so 3 times 0 is just equal to 0. So if I were plotting my values here, that's my first point. And notice that this graph here is counting by pi over 2. So the next value that I might plug in be pi over 2. So this will be 3 times the sine of pi over 2. Why don't you go ahead and try that out? So sine of pi over 2 is going to be 1, and 3 times 1 is going to be 3. So this next point is going to be up here. If you haven't already, go ahead and pause the video now and try and complete this now that you've seen a couple of steps, and we'll take a look at the finished product in just a second. Alright, so here we finished this out, and this shouldn't have been too challenging of a task for us. Notice that we're just multiplying all the values that we had before of sine of x by 3, and so when sine is 1, for example, at pi over 2, we multiply by 3 and we get 3. When sine is negative 1, we multiply by 3 and get negative 3. So I can just make sure that these values are labeled here. I kind of didn't label them on purpose so that you didn't just kind of guess. All right, so now our goal is going to be to identify the midline, amplitude, and period. So go ahead and pause the video now and determine the midline, the amplitude, and the period, and I'm abbreviating them as ML, A, and P. Okay, so the midline is, of course, halfway in between the maximal line, and the maximal line is, the maximum point, and that would be y equals 3, and the minimum point is negative 3, and so the midline is halfway in between, which is y equals 0. And the amplitude is going to be the distance from the maximal point to the midline, and that is the distance of 3, and so the amplitude is going to be 3. The period is the distance it takes to go from one maximum point to another maximum point. And here it might be helpful to look at the unit circle. So the maximum point occurred at pi over 2, right? And that maximum point was 3. When will I get back to 3? Well, just knowing our unit circle, to get back to that maximum point, we have to go all the way around the circle again. So to get back to this value of 3, I'm going to have to go to pi, then to 3 pi over 2, then 2 pi, and then the next one is going to get me back. So that's going to be 5 pi over 2. And so that's one time around the circle, and that's going to be 2 pi. Right? It takes 2 pi radians to go all the way around the circle, and so that's when my next maximum value will occur. So if I had 5 pi over 2 here, that might happen right there. Seems to be a little higher than we were before, but you should understand. Okay? All right, let's try a couple more. You 2 more functions to graph and identify the midline, amplitude, and period. You're going to try these on your own and then compare with your teammates tomorrow. So it's important that you actually get these done so that you have something to compare. If you need to make a table, and make sure that you identify the midline, amplitude, and period. So I'll give you a few more seconds on this one, and then I'll go to the next one. Right, I hope that these went well. Make sure that this is just x over 2, so this is nothing too crazy. You know what to do here. Give it a try, and we'll take a look tomorrow.